We will continue doing some work solving quadratic equations using the quadratic formula. But there's some things that are going to come up that are going to limit us, mostly because we're doing distance learning right now. So I want to make you aware of those things, and that's what this video is for. So if we're going to use the quadratic formula to solve, we're going to first of all make sure the equation is equal to 0. So I want to add n squared to both sides. Making my new quadratic 9n squared plus 4n minus 16 equals 0. Now, when you learned to use the quadratic formula, I think I might have failed to mention in my video that to me the quadratic formula is a last resort. If I can solve this by factoring or taking the square root, I'm going to do that first. If the directions say use the quadratic formula, then I'm going to use the quadratic formula. But if they specify that I can use whatever method I want, then I'm going to use whatever method I want. And the only reason I'm saying this is because your practice for not today's practice, but the next day's practice is going to say that you can use whatever method we've learned so far that you want to. Factoring, taking the square root, or quadratic formula. Now in this one I'm not going to want to take the square root because I have a middle term with an n in it. So taking the square root won't work very well. If I want to consider factoring, remember our diamonds for this, I would do 9 times negative 16, which is negative 144, and then I have a 4 in the middle. So now I would want to find factors of negative 144 that add up to 4. So before I started my video, I went through and looked at some of these factors. One of them has to be negative, and it's going to have to be the smaller of the two factors. These are much more than 4 apart, so this is not going to work. Negative 2 times 72 gives me negative 144. Again, much more than 4 apart. So I kind of just kept going, finding my factors of 144. And I checked, of course 5 is not going to go into 144. I checked 7, does not go into 144. One I forgot, I think, is 9. 16 times, but again, it's, whoops, sorry, I was thinking 144, and I wrote 144. It should be 18. Excuse me. Negative 9, negative 10 is not going to go into 144. I checked 11, 11 does not. And then when we get to 12, negative 12 times 12, they are not 4 apart. So I've already checked 13, 14, and 15 in between here. 17 does not. I've checked that. 19 does not. 20 does not. 21, 22, 23. If it did, they would have come up when I was testing these numbers over here. So my factors of negative 144 are not, I don't have any that are 4 units apart. So that tells me that factoring won't work well for this problem, and I'm going to have to use the quadratic formula. Please keep in mind the quadratic formula works every single time. So you could always go to the quadratic formula first if you wanted, although sometimes the quadratic formula is more time consuming. If you have gotten really good at factoring, the quadratic formula would be a longer process for you. But in this case, I don't have a choice. So the opposite of b plus or minus b squared, which is going to be 16, minus 4 times a times c, and that's all over 2 times a, which a is 9. And I should have maybe written over here, you know, a is 9, b is 4, c is negative 16. You want to continue to identify those. I just identified them right in the equation as I was filling in the quadratic formula. So now I want to clean this up a little bit. And I think I'm gonna do it right within the formula. I'm gonna erase and rewrite only because my space is limited right here. I like to be able to zoom in for you so that you can see it easily, but then that shortens up the space that I have to work in the frame of the video. So I have to multiply these all together, and I know that a negative times a negative is gonna become positive. So now I just have to figure out what I get when I multiply those together. And that is 576. But I have to add 16 to it. So 576 was going to be 592 when I add 16 to it. 2 times 9 is 18. Okay, now, if you recall, not last week, but the week before, and maybe it was the beginning of last week, I taught you how you can simplify a radicand like this. Okay, you can break it down into its prime factors and then you can find pairs of prime factors that are the same. So at this point, that is what we would normally do. The problem with our distance learning is if I simplify this to its simplest radical form, it's going to have a square root sign left in the answer. And for some of this practice, I want you to be able to write out your answers and not select them from a list that I'm providing you with. And I realized that for you to type in the square root is going to be difficult in some cases. So I'm going to show you what this would look like in simplest radical form, and then I'm going to show you what it's going to look like in the way that you're going to have to be able to type your answers in for distance learning. So normally what I would do is I would find out my factors of 592. I know it's even, so 2 has to go in there, and 2 goes in there 296 times. Well, 296 is even. So I know 2 goes in there, and it should go in there 148 times, I believe. 148 is even. 74. 74 is even. And 37 is a prime number. I can't go any farther. So for the purpose of this, I have two pairs of 2's. So I would be able to take the square root of both of them. Okay, because here's where I'm at right now. For the square root of 592. It's 2 times 2 times 2 times 2 times 37. That's what the 592 is equal to. I can take the square root of this pair of 2's, so that one's coming out. I can take the square root of this pair of 2's, so that 2 comes out. And I'm left with my 37 inside of the radical, and 2 times 2 is 4. So that means I would keep the 37 in here and put a 4 right here. Now, there's some simplifying that can be done to this final answer. The numbers outside of the radical, the -4, the 4 in front of the radical sign, and the 18, all can be divided by 2. So I would do that. I would cut them all in half. I can't do it to what's inside of the radical. It's almost as if they're not like terms, really. That's a 3. And then divide by 18 is 9. So this would be my answer in simplest radical form. Do you see how hard it would be to type that into a Google Classroom assignment for you? You could break them apart into 2 separate ones with the plus sign in one, which is what we'll have to do here in a bit to type it into the calculator anyway, and a minus sign in the other. But it's still, not all of you are going to have the ability to type the square root. I've been struggling with finding ways to type the square root in Google Classroom myself. So I know that if I am, I know that you will too. So here's what you're going to do instead. We're going to go back to where we were before we did all of this stuff. Okay? And I know we've practiced doing all this prime factorization stuff, but Unfortunately, I didn't think ahead as to how hard it would be for you to type that radical in. So what you're going to do at this point to get your decimal answer is you're going to type this into the calculator 2 times. One, you're going to type in with a plus sign and figure out what it's equal to, and once you're going to type in with a minus sign and figure out what it's equal to. Okay? And these are all n's. So n equals, make a space in there. I'm going to go to my calculator, try to show you what I'm typing in here. -4 plus the square root of 592, and I'm going to hit enter on that. Some of you might find out that it's easier to type in the square root of 592 first and then add -4 based on the calculator that you're using. Okay, but I'm going to hit enter, and then I have to take that answer and divide it by 18. So now I'm going to hit divide 18. And I find out that one of my solutions is 1 and, we're going to round to the hundredths place, so 1 and 13/100ths. Okay, now I'm going to type in the same thing, but instead of adding the square root of 592, I'm going to subtract the square root of 592. I'll clear that out. -4 minus the square root of 592. And then I have to divide by 18 again. And you might think, well, you're going to get the same answer. No, adding the square root of 592 is much different than subtracting the square root of 592. The square root of 592 is bigger than -4 here. So that's why this one came out positive. But here I'm combining 2 negative numbers. So my negative is going to get bigger. Divide by 18, I'm still going to have a negative answer. And again, it was -1 and 57/100ths. So then I would come over here and say n equals -1, 57/100ths. And this is what it's going to look like when you type it in. And actually, I gave you some notes in your problem so that you would know how to type it. Variable, space, equals, space, and then your answer. If it requires a negative, you'll put it right in front of the number and not put a space in between the number and the negative sign.